Hello and welcome back. And in this video today, we are going to be talking about animation curve. So basically how animation plays out with this animation curve and how it varies for different values throughout the time. So basically animation curve is simply the type of animation, simply the animation, how it's going to interpolate the value of the property over time and how it's going to basically end. So you're going to see, like, when you're going to see the example, you're going to see what I'm talking about, but it's basically interpolating the values of the property that you're animating over time and then how it ends and how it varies basically by applying different sort of options that are available in SwiftUI. Okay, so let's go ahead and get started. What we're going to do is we're going to create first a new view. So I'm going to create a struct. We're going to call this ball view. We're going to have, like, some circular balls bouncing around on the screen. So I'm going to take three properties for this. You can take color, animation, and we're going to bind the position, which is going to be of type CG size. Then we're going to create our body property. And in this body property, we're simply going to create a circle that is going to have a fill of radial gradient. And we're going to create our gradient with colors, and the color array is going to take white color and the color that's been supplied. So white color can come on the center and the other color basically sort of fade out from the center. So for that reason, we're going to keep our center at the center of the unit point, and our start radius is going to be 1, and our end radius is going to be maybe 30 points. Okay. And that's our fill. Then we're gonna need frame to basically define its width and height. I'm gonna create 50-50 for width and height. And then we're gonna create the animation, and we're gonna simply say animation that's been passed to us. Gonna take that. Gonna apply repeat forever. The reverse true, and we can also control the speed. This is basically the speed by which the animation is going to run. As the documentation explains, you can actually clearly see it. We're going to use the same value. We're going to use 0.25 is going to be too slow, so let's do 0.5. Okay, and this is our ball view that we're going to use. So let's go ahead and replace this with a VStack in the body, in the main body property, and we're going to create our ball view. All right, and once again, this ball view takes things, so we're going to create a red color ball with animation default. Let's start with default, and we need a state variable, so let's create add state private var position, and we're going to create a CG size actually. So basically what's going to happen, because you're using VStack, everything is going to be centered on the screen. We don't want to create it as a center, so you're going to offset a little bit. So we're going to say our width is going to be -140, height is going to be 10. Okay, and let me create first so we can see how is it looking. So we're going to resume and see how our red ball on the screen looks like. So there we go, and it looks like this. Let's see if I play this. Okay, so its offset should be let's see if we are applying the offset. Oh, okay. Well, we forgot to apply the offset, so let's go ahead and apply the offset. And we're gonna need that because we're gonna animate that property. There we go. It's looking perfect. Okay, so with that, let's go ahead and copy this, and I'm gonna paste it a few times to create a few more colorful circles. Gonna have green, gonna have orange, maybe a purple. Okay, let's leave it at that. I don't think we're gonna need that one, so we can just get rid of it. And let's try out different animation options. So all these values that are listed, like first one that we have is default, then ease in out, ease out, and linear. These are actually timing curve, and you're gonna see how they differ, how they affect the property basically being animated over time. So that's why I had like a whole bunch of these created, so you can see the effect of these being applied in real time on each individual of these circles. So with this, let's go ahead and put a common on appear block, and we're gonna update our position, CG size, width, let's give it 140, and then okay. With that, let's go ahead and run this, and as you can see, all these balls start at the same point, ends at the same point, but the animation that's been applied is very different. So default goes in with ease in and out. That's the default because that's actually more natural to our eyes. When an object in real world moves through the space, basically it starts slow, picks up the speed, it maintains the speed. When it's about to stop, it actually slows down first and then stops. It doesn't abruptly stop. So that's the animation that's defined as ease in and out, and that's actually mostly the default for majority of the scenarios, majority of the frameworks. So SwiftUI follows the same standard. Now what ease in means is that your animation is going to start slow, picks up the speed, and then it's going to retain that speed and abruptly stop. So it kind of like feels like a little bit jerky. As you can see, it starts good, but it actually stops abruptly. Okay, then you can see ease in and out. So red and green ball are following the exact same path because you can see the default is actually ease in and out. Now it comes to ease out. Ease out is basically the animation starts with a jerk, like so basically starts with a speed but stops with after slowing it down. So as you can see, the yellow ball here starts very fast, but then it actually moves and stops slowly. Okay, so let me change the animation speed so we can actually see this in effect. Okay, so let me restart the animation. So as you can see now, how we are actually seeing this effect. And linear is the most unnatural way of seeing the motion, because the linear defines the time curve that does not change over time. It's actually static. It's like linearly growing in time. Okay, so it's always same. So as you can see in this example, is basically different time curves being applied. Now, just keep in mind that all the objects, all the balls, it doesn't matter if they look like they're stopping at a different point, but they're stopping at the same point. Their position and everything is same. It's just a timing curve. That means the animation effect that's taking place between the start and the end is what's affecting their way of behaving and moving through the space. Okay, so hope that gives you a good idea of how to choose your timing curve, or how to choose your animation with different time curve for your need, for your view, whenever you are in need and you're actually looking for animation to play. Okay, so hope this video was insightful, and thanks again for watching. I will see you guys in next video. Thank you.